Hello and welcome back to your favorite class, INST326. All right, so we just went over objects, but as part of that, right, there's also some more advanced things we can do with container data types. So you might ask, what does that even mean? Like a shipping container, cargo? What are we talking about here? No. So container data types, actually, you've already been introduced to them. So strings, right? Lists, those are container data types. But there's actually more things that we can do. So for example, we can actually do things like tuples or dictionaries or sets, right? All of these interesting things. So what we're going to cover in this module is basically how to use those and the kind of cool, interesting things we can actually do with that. So with that, let's go ahead, get started, and hop right in. What I'll be doing for this lecture is also kind of like going side by side, trying to like go between VS Code to show things because I think that'll be useful. But anyway, let's hop right in. All right. So, like I said, Module 5, Container Data Types. So, in terms of Python, there's a few different containers that we can use. So first, there are ordered versus unordered containers, mutable versus immutable containers, hashable versus unhashable containers, and then mapping versus non-mapping containers. Okay, so what do each of these means, right? So ordered versus unordered is kind of straightforward, right? So strings and lists are ordered, right? So the order matters, right? And the order is guaranteed. Now, mutable, on the other hand, versus immutable means that it changes or it can change. So, for example, a list is mutable, right? As in you can append to a list. And then there's hashable versus unhashable. Now that basically means can we hash it? And we'll talk more about that in a bit. And then also mapping versus non-mapping, which we'll talk about in a bit. All right, so let's hop right into it. So first is ordered versus ordered, right? So in Python, you can have ordered containers, meaning that the sequence of these containers or the items in these containers is guaranteed. And that, for example, is a list. But you can also have instances where the sequence is not guaranteed. So what we'll be talking about in a bit is something called a set. A set does not guarantee the order. All it guarantees is that the objects will exist, right? So if you look at the example, right? So what we're seeing here is that this, for example, right, is like an ordered list, right? Toyota, Honda, blah, 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 all in order. But then here, this is more like a set where all the objects exist, but you can't just say object at 0 because there's no guarantee that that is the same object, right? Now, mutable versus immutable. So mutable means like the value of it can change. So the value of a mutable object can change, right? So it's interesting. So it's kind of like you can mute this thing, right? It's like on a computer, you can click the mute button, right? So it's mutable, right? So some operations on mutable objects change the value of the object. For example, right? If you use the append method, right? We have the append method on lists, right? That changes the list, right? Because a new object is now appended to the list. And you can take a look here, right? L is equal to hello, L dot append. So that's mutable because we're appending to the list, setting a key. But now, on the other hand, all operations on immutable objects actually become new objects. So what does that mean? So, for example, we've done this where we say string dot toUpper or string dot strip, right? So that actually is creating a new object. So for example, if I do s is equal to hello, and then s is equal to s plus world, that is actually not the same object, right? Because what's happening is the hash of that underlying object is actually changing, right? It's actually a new declaration of the object, right? And that's indicated by this s equals, which basically is saying, hey, here's s, reassign it to whatever the current values of s is plus world, right? Versus here, we're saying, okay, well, here's L, just add to L, right? So that's the very big difference. So mutable versus immutable is a very big difference, right? And so though a string here, we're basically acting like it's mutable, it is not. This is true immutability. So redefining a variable does not equal changing the value of an object, right? It is actually redefining it, right? So it's creating a new instance of that object with the same name, effectively. All right, and then hashable versus unhashable. So there is this hash function which maps values to numbers. In a hash table, those values represent bins, basically, right? So think of it like little bins where items can be stored. So you have something in bin 1, bin 2, bin 3. And the benefit of hash tables is that retrieving data is really quick because you know the hash and you look in the corresponding bin. So some of you might have heard of this concept of big O notation, right? So basically, if any of you ever do software engineering, you'll probably ever have to do a lead code test, and they'll tell you, hey, like, can you find the most efficient pattern to solve this problem? So the smallest is O of 1, basically saying that, hey, I don't have to go through the object, I can just immediately get it. But then the slowest, and there's very slow ones, you could do O of n squared, etc., O of n, whatever. But hash tables are closer to O of 1, right? Because basically, you know exactly where to look, so you go exactly to that bin. Versus a list, you have to actually go through the whole list and look for it. So you're saying, is the letter A here? Is it 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 here? Right? Versus a hash table, you're like saying, oh, here's the hash of that object. I know this hash is in this location, so I'm just going to go get it. So it's O of 1, effectively. So Python uses hash tables to implement these things called dictionaries and sets, right, which are very nice. And mutable objects in Python are unhashable, right, because their value could change, so their hash could change, right? So that implies that if something is hashable, it must be mutable, right? Basically, if something is hashable, it must be mutable. But because it's mutable does not necessarily mean it's hashable, but if it's hashable, then it must be mutable, right? Or, sorry, if it's mutable, then it's unhashable. Sorry, I switched my term. So if it's mutable, it's unhashable, versus if it's immutable, then it is hashable, right? So, yeah. Okay. So now let's talk about our first data structure, tuples. So tuples are immutable ordered sequences. So they're made with commas. And tuples are basically made, empty tuples can be made with parentheses. So sometimes parentheses are needed for disambiguation. And tuples can contain any objects. And tuples are also hashable if their contents are hashable. Right? So let's take a look at this. So here we have a tuple. So how did we create? So we created number tuple equal to 1, 2, 3. Same thing, 1, 2, 2, 3. One item tuple is equal to just item, comma, and then empty is equal to just a parentheses. And then what you can do is you can say, hey, my list at append, and then here what you're appending is parentheses, which indicates it's a tuple. Right? And then there's also nested tuples. So you could do like nested 5, 3, 7, 9, etc. So the tuple interface converts, you can actually have the tuple function convert other containers to tuples. So tuples can be indexed and sliced. And so tuples have an index method that returns the index of a specific item, right? And that's because, remember here, they are ordered. So we can actually get the order. And if it doesn't exist, a value error is found. So here, for example, we have tuple George Washington 1732 222, and you have tuple 0, tuple 2, tuple 5, right? So it's very, very similar to an array, actually, right? It's not very far off, right? But you can actually have tuples within arrays, right? And you might want a tuple because a tuple might contain like a container of certain things, right? Array, I'm saying list. But tuples are just like lists, very similar, but yeah. And so the benefit of a tuple is that basically it can return like multiple values. So for example, let's say you have get position here. It's an angle and a dist. It returns x comma y, right? So you're packing that into a tuple, right? And then when you unpack it, it just becomes x1 comma y1 is equal to get position 60 comma 12. Line is equal to blah. Department comma num is line equal to split. Line dot split. And so you made it a tuple, right? Or you can also do swapping. So you could do title comma salary is equal to data scientist comma 75,000. Or you can do A comma B equal to B comma A, right? And then also you can unpack it using a for loop. So you can do for name comma age in people, right? A people is a list of tuples or a set of tuples, I guess. And then print name is age years old, right? So tuples are very useful when the sequence won't change and you need to group dissimilar values, for example, name and age and salary. And you need a sequence to be a key in a dictionary or item in a set. But lists, on the other hand, are preferable when the sequence needs to be able to change and the items in the sequence are all the same kind of thing. Lists of tuples are very common and useful, right? So like if we go back to here, right? best thing about tuples is that they're immutable, right? So they cannot be modified ever, right? So that's the benefit of them, right? So that also means inherently they're hashable, right? So let's go ahead here and actually try to create a tuple. So let me go here, right? So I already set this up, ignoring that, just so we have something to go off of, right? So all right. So the first thing I'm going to show you is, if you remember actually in the slide, what, let me see if I can pull it up really quick, is you saw this kind of interesting thing, right? And so what it's showing here is that if you look at it, right, it's basically showing that we're returning x comma y. And you might be like, oh, that's just returning two variables. But what's really interesting here is that tuples are actually the underlying mechanism that allows you to return two variables. So what's happening here is this is returning a tuple, which is just two variables, right? And you saw this actually in, I think, lecture in module 3, we talked about it, right? How we could return multiple variables. And this is what allows it, because basically a tuple is the underlying mechanism that allows for such a thing to happen, right? So we've kind of already gone over this, right? But we can definitely try again. So what we can do is just do def testing tuple returns, right? And here what we'll do is just do a simple return. Well, we'll create x is equal to, let's do a list of 1, 2, and then y is equal to hello, right? And then return x comma y, right? And so here we just go back, and here what we can do is do testing tuple returns, and what we can do is we can actually set x is equal to and see what happens. So let's print x, okay? And let's go ahead, Python, and you'll see, look at that, function testing tuple returns at blah blah blah. See? So what's happening is, because it's a tuple, right, it's actually returning the hash of the tuple, right? So now if I change this to x comma y, right, and do it again, you'll see, oh, cannot unpack non-iterable function, right? So, oh, wait, sorry. Oh, man, I made a mistake. Sorry. Okay, there you go. So what you can see is when I set it to just x, right, it actually just returns 1, 2, hello, right? So it's actually returning the whole thing, because the whole thing is actually a tuple, right? Now when I do comma y, it destructures it, right? So it basically says, oh, I know that this is a tuple, so I'm just going to make it two different objects. So now it's saying, okay, here's just x, right? So if we did print x comma y, right, you'll see, look at that. So isn't that really cool? So these are the things that we didn't even know were happening, but behind the scenes, this is actually what a tuple is, right? And then of course you can also just make plain tuples, right? So you can of course just say, let's say tuple A is equal to, and you just do, let's just do John, comma, let's say age of, I don't know, 53, I don't know, and then print tuple A, right? Let's just do that, tuple underscore A, right? Print that out, and you can see John comma 53, and then of course you can also do indexing. So at 0, like an array or list, perfect, right? So that's pretty cool, right? Tuples are pretty nice, very easy. They make our life a lot easier. Okay. So now, dictionaries, all right? Let me go grab the Merriam-Webster I have somewhere in the back here. No, I'm kidding. So dictionaries. So dictionaries in Python, weird name for it to be honest, but I get it kind of. Because if you actually think about it, what is a dictionary, right? It's a key to a value, right? It's always a word to a definition, right? So it's a key to value. I was like, that's actually like kind of like genius when you think about it. Instead of calling it a map or something, right? It's very nice. But okay, so a dictionary helps map keys to values for easy lookup, right? So that's exactly how you would remember it, right? So an ID number to a name, a country to capital city, a shortened URL to a full URL, or a word to a definition. It's a dictionary, right? And so what's cool about dictionaries is they're mutable, right? So you can update them anytime, but of course, because of that, they are unhashable, right? Dictionary keys are ordered, right? And can only be hashable objects. Dictionary values, though, can be any objects, which is a little weird. You just said, hey, wait, they're unhashable, right? So what's interesting is the dictionary keys themselves um, can only be hashable objects, right? So a dictionary key cannot be another dictionary, but it can be a list, or maybe not a list, but it can be a tuple, right? It can be a string, it can be an int, it can be any of those, right? But dictionary values could be another dictionary, right? Or something like that. So there's all kinds of interesting things we can do. So how do we use this? So, well, creating a dictionary is easy, right? All we do is, as you can see here, is we use curly braces. So empty dict is equal to curly braces, alternative is equal to dict parentheses. So both of these exist as ways to create a dictionary, right? And when you create this dictionary, you do key colon value, which you can see here. So let's say you want to create a new dictionary, you'd have it in curly braces, you would have the key, so for example English, and say hello, French, bonjour, whatever language this is, right? All of them, right? Then you can also access it just like you would do an array, but a little bit better. So what you can do is, instead of, obviously you cannot reference the order because the order doesn't exist, you can do greeting at the value. So, or at the key, right? So greeting at Spanish, right? So if Spanish was an example, you can do greeting at key, right? You can't do greeting at the index, but you can do greeting at the key, right? And then also you can have a safe access, so you could do greeting.get, right? And if something doesn't exist, it'll default to hello or something, right? And then you can also add new keys. So you can say greeting at Samoan is equal to Talofa, or you can update an existing value. So you can say greeting at English is equal to hi, right? So it's very similar to other objects, but it's a much simpler, like kind of, and flexible kind of way. So a key value is a very common trend that we tend to use. And then we can actually iterate over dictionary. So how do we do that? Well, as an iterable, a dictionary really is just a sequence of keys. So you can say, hey, for language in greetings, print in language you greet someone by saying greetings at language, right? So at key, right? So language is a key. So for example, let me see if I can pull this up here, right? So let's say I had a greetings equal to curly brace, let's just say English, hello, and ignore that I forgot the quotes, but for now we'll just do that. Spanish colon hola. Okay, other quotes here. Okay, great. So what would happen is, right, first thing you would say, great. Let's see if I can do this, right? So first thing that would happen here is you would say print for language in greetings, right? So language would be English and Spanish, right? So for English, and then for Spanish, in Spanish you greet someone by saying greetings at, and then language. So your language here would be English or hello, right? And then if blah 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 in greetings, print I know blah blah blah, right? And I think I forgot to tab this, but I think you get the idea, right? You could also convert it to a list. So languages is equal to list of greetings. And if blah, blah, blah in greetings, print I know blah, 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 right? So you can convert it easily to other things. And then you could also use the dict.items. So what you could do here is you could say language comma greeting in greetings.items, right? And this is really nice because then you don't need to do greetings at items, right? Like here we were doing greetings at language. Here you don't have to do that. Here you can just say for each language and each greeting, in language you get blah, blah, blah. So it's like you're destructuring it into a tuple almost, actually. And then greeting contents is equal to list at greetings.items, right? So you can do that as well. And then if you need just the values, you can do for greeting in greetings.values, and then it'll just say print greeting in title case is a greeting, right? And then make a list of greetings.value, right? Super easy. And then you can actually manipulate dictionaries very easily. So you can do a delete dictionary at key, so that'll delete French, or dict.pop will pop out French. It's the same thing effectively, no fundamental difference. And then to copy a dictionary, you'd have to do a dict.copy, right? So this is a deep copy, so it creates a new object, right? So so that you don't actually reference the whole dictionary object. Right? So here's an example of a basic use of a dictionary. So you might have electricity prices is equal to super off-peak, peak, tier equals peak, amount equals 312, price is equal to electricity prices at tier times amount, right? Simple, right? Now, at the same time, you might have something like this, right? Electricity at prices at tier at peak would go to 0.17 times amount 3.12, right? So you basically say electricity prices at tier, right? Go to here, tier is peak. So it'd go here, and then this is the value it would get, 17 times amount, right? Now, also, you can count with your dictionary. So what you can do is you can do for word in words, right? Counts at word is equal to counts.getWord, comma 0 plus 1, right? So what's happening here is you're creating a new counts dictionary, and then you're saying for each word, so for counts at word, so for example, counts at in is equal to counts.getWord, right? So this new dictionary, right? And if there is nothing, it defaults to 0, right? And then plus 1. And then otherwise, right, if it exists, right, it gets whatever the default value is, right, plus 1, right? So in would go, and then counts at in is equal to blah, right? And then the blah, 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 and then it goes to in again, and then it would say, oh, in exists, so let me just increment it plus 1. And then you would print word occurred X amount of times, something like that. Right? Okay, so now let's hop on over to here and actually show how dictionaries can work. So we'll actually use that kind of example we saw, sort of. So I don't, so let's comment this out, then print this. Actually, we can just delete this. We'll just keep reusing this, okay? All right, so here what we'll do is we will create a, let's call it a word list. Word list is equal to, let's do dictionary here. Or let's do word list is equal to array. So a list, right? Actually, no, here's what I want to do. Okay, let's do two things. So first, let's just do some basic dictionary. So dictionary is equal to, or let's call it word dictionary. So we'll say curly brace, hello, and then we'll say a greeting to a greeting for others in English. Right? If I could spell, of course, but you know. Okay, and then we'd say bye. For example, say the opposite of hello. I don't feel like trying to look up the definition, right? Okay, cool. And so now what we can do is we can actually print this. So let's just do a print word dictionary and see what pops up. Word dictionary. Let's just go here. And you can see, great, it printed in curly braces. But now we can do print at word dictionary at bye. Right? So let's see what happens here. The opposite of hello. Cool, right? That's pretty cool, right? Now, also, we can iterate through this list. So what we can do is we can do for let's do word, comma, definition in word dictionary dot items, right? And then do print, and then do word, colon, comma, word. And then print definition, comma, definition, and then just do a print. Perfect. And then do Python 3. Perfect. Look at that. So that's so cool, right? So you have a key value mapping here. Now, what's cool is you could also do something else, right? So for example, you could actually have a dictionary with other dictionaries inside it. So for example, right? So let's say we change this. Instead of word dictionary, so we say hello, right? Here, what we'll do is we'll convert this to another dictionary. And in this dictionary, we'll have something like, let's say here we will have definition, colon, right? And then maybe we'll have like etymology or something, right? Etymology. I honestly don't know the etymology, but Roman, Greek, something. I don't know. But look at that. So now hello has another dictionary nested inside it. So now let's run our program again. So now you can see hello has a definition and it's another dictionary, right? So that's pretty cool, right? And then, of course, what we can do is also the benefit of dictionaries is they cannot have the same value twice, or the same key twice, right? So, for example, let's go ahead and we're going to try this again. So we're going to say hello again, or no, let's do bye again. No, let's do hello again, and we will do something different here where we'll say hello, comma, and then we'll say I replaced this, and then say replaced. All right, cool. And then you can see here actually there's a warning because of rough, and it's saying, hey, this is duplicated. So let's see what happens. So now look at this. So because we declared it again, it just replaced what was in the first key, right? So you can only have it once, right? And it'll always take the latest version of it. Even if I change the type, right? So for example, if I said 15 here, right? If you look here, it'll change it to 15, right? Even if the type completely changes. So that's one of the key things about dictionaries. The keys cannot ever be duplicated. You can, of course, have the same values. So for example, let's say I call this hello 2, and I had the exact same value here, right? That's fine. You see, that'll become a totally different thing, right? So that's fine, but it cannot ever be the same key because the key is basically a hash. So it needs to be able to look up that hash very quickly. So that's really important, right? And so if you remember from this example here, we're actually going to run it, right? And I'm going to explain what's happening here. So I'm going to copy it here and then just put this here, then delete this, put this here. Okay, so if you look at this and go tab this, okay, so this is way too many. So I'm going to go to here just because it's too much otherwise. Okay, so here, what we're doing here is we're creating a dictionary called counts and what's going on? Okay, so here what we're saying is counts is equal to dictionary for word in words. Counts at word is equal to counts.getWord plus 1, right? What we're doing here is for word in counts, right? So for word in counts. So what we actually showed is for word comma count in counts. I made a mistake here. For word. Yeah, let's just do that. Count. Here we should say occurred count times. Okay, and let's go ahead and print this. And there you go. I made a mistake. For word in counts. Why is it? Okay, try this again. What? Word comma count. In counts. Counts at word. Is equal to counts.get word comma 0 plus 1. Okay, for word in words. Words is here. Yeah, so counts at word, which is dictionary, right, is equal to counts.getWord comma or at 0. So let's just go ahead and print counts to see what I did wrong, because I am human and make a mistake. Print counts. Let's see what happens. Okay, so it says in comma 1. Okay. Okay, you know what I did? So it looks good, but I made a mistake. So this should be counts.items, right? And so if we go here, there you go. In occurred 1 time, the occurred 2 times, blah, 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 right? So you can see because in is, or sorry, the is twice, right? So you can see it's in 2 places. So it's incrementing, right? So it's saying for word and words, so go 1 by 1. Counts at in is equal to 0. Counts at the is equal to 1. Counts at end is equal to 1. Counts at it is equal to 1. Counts at not is equal to 1. Counts at the now equals 2. So pretty nice, right? So it's a good way to keep track. Okay, so pretty nice, chill, easy way to do it, right? So dictionaries are very nice. Highly recommend using them generally. Okay, now sets. So sets are unordered, mutable, unhashable collections of unique values. That sounds insane. You're like, huh, that's okay, interesting. But the definition of sets is really because they focus on membership. So what's really cool about of sets is that they actually help you eliminate duplicates because they have no duplicates, and they come with a rich set of operations. And they're really useful for actually more kind of mathematical operations in a sense, right? So they help you eliminate duplicates, find unique values, filter groups of values, handling groups of values irrespective of orders, right? So they allow you to do a lot more of these math operations, which typically take a lot more work to do. Okay, so how do we create sets? Well, they're really easy. So first, you can just do equals set parentheses. You might look at this and be like, whoa, that's too easy. It is. And then you could also do something like this where you use curly braces and just create a list of values, basically. Or you can take a list and then say set of list, right? And that's really beneficial because if you have duplicates in the list, it'll immediately remove them. So there's some nice things to do. Now, for sets, there's actually different ways you can do operations. So there's methods and operators. So there's basic operations, which result in new sets. And then there's in-place operations, which actually change the value of an existing set. Generally, I'll be honest, the basic ones are good. They're just easier. But the in-place operations are also useful, but usually I go with basic ones. So let's first take a look. So first is a union. So if we have a union, which means join everything, join all the values of two sets, right? You can do a set1 dot union set2, right? Or you can do set1 pipe set2. Or you can also do an in-place update by doing set1 dot update set2, or do a pipe equals, which is basically the in-place operator. Then you can also do an intersection, which helps you find the intersection, aka the common values between two sets, right? And one thing to note is when you do something like this, it will deduplicate. So if you have two sets, it will deduplicate the sets, right? And then same intersection. So intersection, you just do dot intersection or an ampersand, right? Or you can do an ampersand equal or an intersection update, right? Then there is difference, which basically finds you the difference of two sets and only finds you the unique values in set 1. So set 1 minus set 2, or set 1 minus equal to set 2, or the dot difference update, right? And then there's symmetric difference, which finds a unique one in each set, pretty much the same, right? Yeah, it's pretty much the same thing, right? So yeah, there's basically no difference, as you can see, right? So set 1, set 2, whatever, right? Okay. And then you can also do subset. So you can say, hey, is set 1 a subset of set 2? Or is set 1 a superset of set 2, right? So set A contains set B, blah, 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 right? And then also you can do disjointness, which you can say, hey, are these two sets completely different, right, by using a disjoint? Or you can determine, are these sets exactly the same, right? Because they could have different orders, but they can be the same set, right? And then you can also do other things. So for example, you can get the length, right? Or you can get a membership. So is member item in my set or item not in my set? Or you can do an add. So my set.add item. And you can also remove. So remove item, discard item, pop item, right? Pop will actually remove arbitrary elements. So if you're playing a game of chance, that's one way to do it. And then you can also do mySet.clear, which just removes all elements for sets. And then you can also have a frozen set. A frozen set is interesting because it's an immutable, hashable set. So it has its benefits because it's hashable, but you can't add or remove values from a frozen set. So all basic set operations, like non-in-place operations work, so comparison, stuff like that. But no special syntax is really required for this, right? You just use the frozen set to convert any collection into a frozen set. And sets and frozen sets play nice together. So for example, you could have pets is equal to frozen set blah, and then do mammals is equal to a set, and then do pet mammals is equal to pets and mammals, right? Which would get you the combination, right? So there's all these unique things you can do, right? So there's a lot of great applications for sets. Sets are some of the most valuable. So for example, let's say you want to get the unique values. So what you can do here is you can have all these wait lists, right? And then say, hey, wait list of set waitlist 101, 102, 103, and then get me the unique of that length, which would actually be the joined of all of those. And you would get only the unique names here, right? Or you could find a subset. So for example, you have clients and appointments, right? So you can do sets of clients minus sets of appointments, right? So that would allow you to get a set of those two. So you would see, oh, okay, well, looking at this, right? Torque LLC is both, right? So you found that all the sets of appointments, you found basically who is the subset, right? So, or is Sprocket World, is appointments a subset of clients actually, right? So you see Sprocket World is, Torque is, Gears is, Pinion Balance is, so this would be a subset, right? And then you could also handle groups irrespective of order. So here you can see we have a team list is equal to line.strip.split, and you could say, oh, okay, great, I know the list, right? So for each team is equal to frozen set team list. Matches at teams is equal to matches that get teams at 0 plus 1, right? So just like we were doing in the previous dictionary, we're creating a dictionary based on the unique team list, right? So yeah, pretty useful, right? Because what you would do is you'd get a list of Maryland versus Texas, etc. And yeah, it'd be pretty cool, right? So you'd be able to say, oh, okay, each team plays X amount of matches, right? So there's all these cool things. All right. So with that, let's go ahead, hop on over. We have a little bit of a lab, so let's go ahead and work on some of these concepts. And yeah, we'll go from there. All right, let's hop on over to VS Code. All right. So now welcome back to your favorite program, VS Code. Now, what we're going to do is start by basically, we want to use all these tuples and everything. So what we're going to do is let's go ahead here and in module 5, create a new file. Let's call it shipment. Whoops, it's not working. Try again. Shipment inventory.py. I like that, right? Yeah. So what we'll do is I have a list of inventory. So let's go ahead and create a def main. And in here, I will paste this. Of course, you will have access to my files, but I already predefined this. So if I did this, that would be crazy. Or if you had to type this by hand, that would be kind of useless. And then if underscore name is equal to underscore main, right? And call main, right? Perfect. All right, great. So what are we trying to do? So basically what we want to do is kind of set up a inventory analysis, right? So first thing we're going to do is basically take a list of these shipments and basically create a map of, oh, okay, like what is the most frequent route, what is the least frequent, etc., and keep track of that, right? So let's go ahead and start by doing that. So what we'll do here is we'll go ahead and we'll do a we'll create a route traffic data, I guess. So we'll create a def track route traffic data, or maybe we could call it rank, but either way, all this takes in is going to be our shipment data. So we'll call it shipment data, right? We'll create our JDoc here, and then takes in shipments and tracks the frequency. And then we're going to say returns maybe a dictionary. Let's call it traffic map maybe, and that'll be a dictionary, which will be a what will it be? It'll probably be routes comma count, effectively, right? Okay, so now what we can do is we can create this dictionary. So traffic underscore map is equal to right? And then from there, right, let's take a look at what this kind of shipment data contains. So looking at this, if we do a, so it's already it's a list of dictionaries, it looks like, right? It's a list of dictionaries, right? So what we can do is we can probably just iterate through it, is my guess. So what we can do is something like for, and then so Baltimore Hub, DC Center, so that's probably going to be like your origin, right? Then your destination, right? Because DC Center, yeah, right? And then your SKU and your quantity, right? Quantity, right? In shipments underscore data, right? In shipment data, right? And then what we'll do for now, right, just to validate this assumption, what we'll do is we'll just do a simple print. So we'll do a print origin, comma, origin, right? And then print destination, comma, destination. And these will be deleted, but I want to validate our assumption first that if we take in the list of dictionaries, that this is what will happen, right? And then, or not a list of dictionaries, it's really a list of lists, actually. A SKU. Okay, I think that's enough. We'll be able to find that. So here what we'll do is we'll just say track route traffic data raw shipments feed. Okay, and let's go ahead, run it, make sure this looks good, right? So I said a mistake here. This is actually a list of tuples, right? These are tuples, so it's a list of tuples. Okay, so anyway, let's just make sure it works. So Python 3 shipment inventory. Perfect. Look at that. Origin, Baltimore Hub, destinations DC, SKU 9. Perfect. So this works exactly as we expected, right? So the first thing we need to do is basically keep track of, okay, well, for each origin and destination, like how often are we going between that, right? So for example, like here, we're going between DC Center and Baltimore Hub twice, right? Or Richmond Outpost once, blah, 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 right? So let's see. So what we can do then is we can create a route key, basically, like a route. So what we can do is create a route key, right? So think about this, right? When we have these, right? We don't care, right? Because what we're trying to do is establish traffic patterns. So regardless of if you go from Baltimore to DC or DC to Baltimore, technically those are one route, right? Because those are the same route, doesn't matter the direction, right? So what we should do is store it in a way that technically order doesn't matter, right? So then what that means is really we should have a set, right? So route key is equal to set of origin, comma, destination, right? So what we're saying here is we have this set, right? A set of origin, comma, destination. And since it's a set, the order doesn't actually matter. Shocking, who would have guessed, right? So that's pretty cool, right? And exactly when you print it, you will see exactly that. So if you do a print of route key, right? And we go here and we print, right? You'll see here, DC Center Baltimore Hub, DC Center Baltimore Hub, blah, blah, blah. The order doesn't matter, right? It's printing it in a random order, effectively random, right? So now that we have this random order, what we can do is we can actually say, hey, traffic map at route key is equal to traffic map dot get route key, comma 0 plus 1, right? So what this is saying is, hey, for the traffic map between DC and Baltimore, right? If it exists, then get the value and increment it by 1. If it doesn't exist, get the value, or if it doesn't exist, default to 0, and then increment by 1. So now what we can do is we can actually do a print of traffic map. So let's go ahead and see how it looks here. Oh, sorry, I can't print it. Well, actually, hold on. I know I did something wrong. Da, 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 da. Ah, okay, so interesting. So this is an interesting problem. So if you look here, it says, oh, this is a unhashable type of set, right? And that's true. But what that means is really this needs to become a frozen set, right? Because frozen sets are hashable. So let's do a Python here and, oh, sorry, I forgot to print it, right? That's important. Print traffic map. Okay, go here and go here and look at that. So frozen set Baltimore hub 3 times, Baltimore hub to Richmond once, and Richmond to DC once. That is so cool. So frozen set is really important for a dictionary, right? So if you're going to use a set as a key in a dictionary, it has to be a frozen set, okay? And now you're looking at this and be like, hey, you created this skew and quantity, but you aren't using them. That's true. But in Python, the standard is when we destructure things, we keep all the elements out. Otherwise, it could confuse the compiler, etc. So just easier to have them even if you're not using them. So now we just return the traffic map. Perfect. All right. And so now here we can say traffic count map is equal to whatever we return there. Right? Great. So now we have that. So now we could technically print that, right? Maybe we could make it like look pretty or something. So for maybe example, we could do something like for, let's call it route comma count in route in, oh, I spelled traffic wrong. I'm really bad at typing today. All right, in traffic count map dot items, right? And then do maybe we could do something like let's see, we could do print f colon we could do route was traversed percent count times. So let's go here, and there you go. So you can see frozen set blah 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 was traversed 3 times. The one thing I don't like about that is it says frozen set. That's not exactly how I like that. Should be fine for now. Maybe what we could do is like we could probably change it, but for now that's fine. You could probably destructure the set, right? So you could do route. Yeah, you could destructure the set, but I'm not going to right now. That's fine. Okay. I think you can do route dot. Let's see. Let's see if that works. I don't think that'll work, but we can try. Yeah, no. Anyway, that's fine. Okay, cool. Okay, great. So we can do, oh, you know what you can do? You could do list of route, right? Because now it doesn't matter, but it'll look pretty. There you go, right? So Baltimore hub to DC was traversed 3 times, blah, blah, blah. Nice. Okay, that looks great. All right, so now what we can do is also add in some advanced calculations, right? So for example, like I have a list basically of all these SKUs that are stocked, right? So the SKUs, so mid-Atlantic, whatever. And then we want to be able to identify anomalies. So first thing I'll do is pass in those SKUs. So I already have them. Of course, you can paste them as well. So let me just put those here, right? Go here, right? So we have all these like nice little SKUs that you can put in. But now what we're going to do is basically use like these sets and all these things to find overlapping or like missing inventory, right? So maybe we sent the same thing to multiple places, or one place doesn't have this, right? Or etc., right? So we want to be able to identify that, right? So here we have this, looks good. So what we can do is we can actually create a new method here called definition identify SKU anomalies, maybe. right? And here we would pass in the mid-Atlantic skews, mid-Atlantic skew, northeast skew, and the clearance list. Okay. Okay. So here we will put another doc string, basically say identify overlapping and missing inventory. And then here we're probably going to return a set, probably. So returns, or we can say args. So mid-Atlantic skew. The skews for the mid-Atlantic. And then northeast and clearance. Sorry. Northeast skew. The skews for the northeast. And then clearance skews. Right. So clearance list. So clearance list skew is the skews that are up for clearance. Clearance list skew. Okay, perfect. All right, looks good. And then out of this, you're probably return. Let's see. Returns. Come on. Returns anomalies, right? Which will probably be maybe like a set, probably a set of anomalies. So we'll figure that out. So first thing we're going to do is maybe we'll find all the skews overlapping in the regions, right? So where are there skews that are like shared? So what we can do is we can do a shared skews is equal to mid-Atlantic skew and northeast skew, right? So remember, when you do an and or an ampersand operation, right, that's going to find you your intersection. So where both match. Right, so here what we can do is we can actually print, right, f do overlapping skews, colon, then do shared skews, right? Okay, so now let's say we want to get the total number of skews across both regions, right? So what we can do is get a total skews, right? Total skews, right, is equal to mid-Atlantic pipe northeast, right? So if you look here, the pipe is basically a union operator, right? Now, the one good thing is, even if there are duplicates, because this is set, they will automatically be deduped, right? So what we can do is they say print f and say total unique skews, skews, colon, comma, total skews, right? So since it's a set, it'll dedupe it anyway, so it's great. And then lastly, we can get the active items that are not on the clearance list, right? So these would be anomalies or, you know, like something like that. So we could do anomalies, or we could say items not clearance skews, right? And that would be total it would be total skews minus the clearance list skew. Okay, and then we can just print and say f colon items that are in stock and not in clearance. These seem like very contrived scenarios, and I'll be honest with you, it's because they are, but I'm trying to show you the power of skews. So bear with me. While these might seem like very weird, contrived scenarios, truthfully, they probably are. Right? And honestly, I don't think we need to return anything, so I'm going to get rid of this. So I'm just going to remove this. Okay, yeah, let's run it. So print. Oh, forgot to call the thing, right? Let's just call the identify skew anomalies method. identify skew anomalies, and then that would be mid-Atlantic stock, northeast stock, clearance items. Perfect. And then run it. And look at that. So overlapping skews, total unique skews. So if you count it, right, 1, 2, 3, 4, 5, 6, 7, 8, right? But here in total unique, 1, 2, 3, 4, 5, 6, right? So it removed duplicates, right? So if you look here, 105 was a duplicate, and 100 was a duplicate, right? So it removed those, which is very nice, right? Okay, perfect. All right, and the last thing we're going to do is build like a master list, right? We want to create this nice master audit list, right? So basically create a mutable set of all the locations of our SKUs and everything like that. So that's what we're going to do. All right, so how do we build this out? Well, let's go ahead and create a new definition called build master audit, right? And again, we will take the raw shipments data from there. So we'll do shipments data, right? Perfect. So now here, what we're going to do, create another doc string and say maps complex data to as a key pointing to historical locations, right? And we'll talk about that, right? And I don't think and I think you can return the audit DB, which will be a dictionary, I believe. So let's do a dictionary for now. Right, so what we're going to do is basically say for each SKU, right, say that it's in transit or something, right, so it's in transit, and then basically if the SKU doesn't exist, create a set, and then if it does exist, right, basically add the origin and destination to the keys so that we can actually see, like, for each SKU, where is it, like origin to destination mapping, all those kind of things, right, for each SKU, right? So that's a little confusing, but as we build it out, I think it'll make sense. So what we'll do is we'll create an audit DB, and that'll equal to curly braces, right? And so here, what we're going to do is first, we're going to iterate through like we did up here, right? So I'm going to copy actually this exact thing because that's exactly what we need. Okay, right? And in shipments data, sorry. Okay, right? And so now what we're going to say is, well, what we're going to do is take the SKU, right, and basically create a key out of it. So what we're saying is that for each thing, right, so if you remember, right, if you go here, for each of these SKUs, what it's saying is that from Baltimore to DC, it's in transit, right? So we're going to say for this SKU, currently it's in transit. So we'll do a composite key equal to a tuple of SKU comma in transit, right? So now from there, what we're going to do is basically initialize basically try to see, does that thing exist, right? And if it does, great. Else, if it doesn't, right, then create a set for it, right? And we'll talk about what we want to do with that set, right? So what we're going to do is say if composite key, right? So that's your SKU comma in transit, not in audit DB, right? Then audit DB at composite key is equal to set, right? Okay. And then what we can do is say audit DB at composite key dot add origin, and then also add destination, right? So what that does is basically to a set, you can do a dot add, right? So what we're saying is add the origin and destination to the composite key, right? So now let's just go ahead and print audit DB, right? Let's go see how it looks. Oh, and I forgot to call it, of course, that's important. So let's go ahead and make sure to copy that. and then do build master audit, shipments, raw shipments feed, run it. And you can see here, so it says SKU99 in transit from Richmond Outpost DC Center and Baltimore Hub, right? And then SKU100 in transit, right? DC Center to Baltimore Hub, right? So let's take a look at those SKUs. So here what we're saying is, okay, SKU99, right, is here, right? And that's going from Baltimore Hub to DC Center, and then from Baltimore Hub to Richmond Outpost as well, right? So we're saying SKU99 is in transit for all these three locations, right? And then same for 100, 102, whatever it is, right? So what we're doing is we're adding to the set, right? And so if there's any duplicates, we're just remove it, like the set is removing it automatically, which is great. I'm now realizing this is not a very useful thing. I think we can make it better, but you know, it's okay. Yeah, it's not a really good. I'm just trying to show like how dictionaries and sets can work together and show things, but basically what it's saying is like you know, basically we're trying to say, you know, mapping this complex data to like a set of historical locations, right? So we're basically adding all the historical locations, right? I'm wondering now, do I actually need this? Let's see. Let's try this. Let's see. Try this. Look at this. So the reason I needed this, right, is because in a dictionary, right, if the key doesn't exist, it'll get created. But because we're assuming it's a set, right, it's doing a dot add, right? So pretty interesting. But yeah, just something interesting to note. Okay, with that, that is all I had, right? This was obviously a little more abstract. The lab and stuff will definitely be much more concrete and focused, so you have a much more better idea of what's going on. But this was just kind of to show how you can use dictionaries, how you can use sets, how they react, all those kind of things. So with that, that is all I had. Thank you all, and I will see you in the next module, which will be extending some of these data types. We're going to talk more about container data types, just different ones. And with that, I will see you all in the next module.